Okay, so let us begin. We got to do a few definitions, and then, like I said, after we've done a few definitions, the actual work for today is you already know how to do it. You're just going to apply something else to it. So here we go. A system of equations is a group of two or more So, while you write that down, I'm going to talk for a moment. What do I mean to say an equation has a solution? What does that mean? You don't need to write this down. Does that equation have a solution? What is it? So what's the solution? What does the word solution mean? An answer. Okay. So an answer is when you x equals 3. Thank you, Daniel. Okay, so that equation has a solution. So I'll ask again, what do I mean when I say an equation has a solution? Pardon me? Yeah, there's a number that will make the equation, for lack of a better word, work. Does everybody understand? I could not put 7 there, could I? Because then the equation would not work. Is everybody with me? Okay. So how many solutions does that equation have? 1. 3. Everybody cool? All right. Now, is that a system of equations yet? Why? Because it's only one equation. Everyone agree? Okay. So to make this a system, I would have to add another equation to it. Yes? So is that a system now? Do they share a solution? What is the solution that they share? X equals 3. Is everybody cool? Okay, that's the basics for this whole unit. Does everyone follow that? Now, what if I put a third equation in there? Now, is there a solution to the system? No. Why? Exactly. There is not a solution to all three. Everybody cool? Okay. Let us come back to where we were working earlier. So, we know what a system of equations is. It's got to be a group of at least 2, and they may or may not have a solution. So this is a system that does not have a solution, right? But if I erase the red one, pretend that my computer is working, it does have a solution. Everybody cool? All right. So a linear equation. What's a linear equation? We just did 2 whole units on it. Can somebody actually define a linear equation for me? Warms the cockles of a teacher's heart to see a room full of 30 who just did 2 units on linear equations and no one can tell them what it is. I'll get that. Go for Myers. 8. Uh-huh. Sure. I couldn't care less. Sure. Sounds great. No problem. So I'll ask again. You had some time to think whilst I was on the phone. What is a linear equation? Let's try breaking it down a little more. What's an equation? Okay. A little more than that.
Something that leads you to an answer, like a problem.
Okay.
Yeah.
Carlin?
Isn't a linear equation one step or one step matches part of another step? Or?
Now you're getting somewhere. Yeah, linear equation has to have 2 sets. 2 sets of what? Pardon? Data. Okay. Excellent. And those data are usually referred to as variables.
Yeah.
And what do we know about those variables if it's a linear equation? They're not quite the same. Something about them is the same. If I make a change to one, what happens to the other one? A constant change. If I add 3 to the independent variable, that's going to do something to the dependent variable. If I add 3 again, then that same change will happen to the dependent variable. Right? We all remember this now? All right, so a linear system is, or a linear equation is, there should be an N there, an equation a repeated change to the dependent variable when change is applied to the independent variable. And what does it look like on a graph? A straight line. And every time I go a change there, I get the same change there. So if this is x and y, what is that? X, and how far up will I go? Y, every time. That's what makes it a line. Everybody cool? Not news. Everybody should be okay with that. So what then must a linear system be? If a system is a group of equations, and a linear equation makes this line, what must a linear system be? Follow the clues. Carlin.
More than one equation that results in a change.
So, excellent. A linear system is a group of 2 or more linear equations which may or may not share a solution. Now, up here, I'll go back to this example. The solution could only be an x, yes? Right? because that was the only unknown there. But what if I change this to this? Now, to have the solution, I must not only find the x that works, I must also find what? The y that works. Is everybody with me? So, to solve a linear system means to find the value for your IV and dV that satisfy all the equations. Everybody cool? That's all the theory. We're going to do some stuff with it now. Is everybody good? All right. You're going to learn 3 ways with which to do this. 1, graphing, you already know how to do. Elimination, substitution, you do not, but you know the mechanics of doing it. You already know how to make it happen. You just haven't done it. So we're going to start with graphing. So, the key point when we are solving by graphing, we have to find where the lines cross. Why is that a solution? I'm going to draw a blue line, and I'm going to draw a red line. That's where they cross, correct? Why is that the solution? What is special about that point that means we could say it's the solution? Carla. It's coordinates. So that spot is an X and a Y that does what? Both lines have in common. So if I was going to have this blue line in point slope form, that X and Y would work in it. And if I was going to have this red line in slope intercept form, for example, the X and Y would work on it. Are there any other points in the whole universe where this red line and this blue line would have a solution? No, because they'll never cross again, because they're linear equations. They're never going to turn, are they? Is everybody with me? All right, so let's have a look at this. If we are going to find where they cross by graphing, we must have to graph the lines. How many ways do we have to graph lines? Point slope form, slope intercept form, tables of values, and general, right? You can do any one of them. I, of course, like points or slope intercept form because for this, it's the easiest one to use for me to teach you how to do it. But you have all of those tools at your disposal, right? But I'm going to use slope intercept form. M is the slope, and B is the y-intercept. So step 1, you're going to graph each line. That's easy peasy, right? So you've got to take each equation and manipulate them to graph. So let's do this. We'll take a red equation of 2x plus 7 equals negative y. And then let's go with 3x plus 2y equals, negative 3x plus 2y equals there. Now, what would you do with those two? You can't solve them. You take each equation, you manipulate them so you can graph them. So what would I do with those two to make them so they were easier to graph? What am I going to do with that first one so I can graph them? Yep, all I got to do is make y positive in this case because y is by itself. So what would it be? -7. Excellent. What would you do to this guy? Get y by itself. So y is going to equal 3/2 x minus 6.5, correct? Everyone with me? Then we'd graph them. So the red, oh, I should have done two colors there. Sorry, guys. That guy will do in red. We go down to -7. He's got a slope of -2, right? So down 2 over 1, up 2 over 1, like that. Everybody agree? And this guy is down at -6.5, which is a little bit above, and it's got a slope of 3/2, right? So up 3 over 2, down 3 over 2. There's the cross. And whatever that point is, it has an x and it has a y. And since it's got an x and a y, and both of these have an x and a y, that x can go in there, and it will work. And that y can go in there, and it will work. Does everybody understand the theory? Because remember, from our last 2 units, if we ever have an x and a y that's on the line, we can put it into the equation, right? Everybody good? Okay, let's try this. Turn the page over. Solve these by graphing. Now you'll notice I didn't put a axes for scale on here. Why? Because what if I end up with fractions, right? So, what should I do with A? I'm going to graph him in blue. What should I do with that so I can graph it easily? Pardon? Get y by itself. So that's y equals -x plus 4, yes? And then what should I do with this guy? I'm going to do the same thing with that guy, right? What? 2y is going to be x plus 2, then what? Divide by 2, so y is going to be 1/2 x plus 1. Is everybody good? Do I have to worry about scales? No, because everything's nice. There's no, my intercepts are good. Everything's cool, right? So I'm going to come over here and I'm going to graph them. So where do I go for the blue one? +4. 1, 2, 3, 4. And then I need a slope of -1. So how do I do that? Up 1, left 1. So this line here is everybody cool? Everybody's good? Now, I can connect that line, can I not? Yeah, because it's continuous data. So I'm going to go ahead and I'm going to sketch in that line. Everybody good? Now, the red one, I'm going to do the same thing. I'm going to go to +1, and the slope is +1/2, so it's up 1 over 2. Oh, look. It hits right there. What is that point? 2, 2. So this is what I think the solution is, yes? 2 is an x, 2 is a y. Is there any reason not to get this right? No, because you can check. Is 2 plus 2 4? Yep. Is negative 2 plus 2 times 2, which is 4? Is negative 2 plus 4 positive 2? So it's the right answer. Is everybody good? All you do is graph them and check where they cross. Everybody okay? Great. You guys do the second one. Was everybody good? Okay. Where can you foresee a problem with using graphing to solve these? Because these two worked out perfectly, didn't they? Where could there be a problem with using graphing? Like, why wouldn't we always use graphing? Because I told you there's 3 methods. Anytime there's more than one method to do something, it's because there's times when it's a better way to do it, right? So why would we have 2 other methods for this? The lines might cross at gigantic numbers. What else? How many values exist between there and there for x? Infinite. How many values exist between there and there for y? Infinite, right? So what would happen if our lines crossed in the middle? Can you tell me what the solution there is? No. So that's why we don't use graphing all the time. Everybody cool? Now I'm going to show you something that isn't really part of grade 10, but you're going to see it next year, and it applies to what we're doing here. Everybody could graph this one, right? Easy peasy. Go ahead and graph it. Just graph the second one there. Everybody good? Now, we've got this first one here. Does anybody know what that notation means? Anybody. I wouldn't expect many of you to, unless you're from another country. You guys know what it is? No? Nobody? Okay, this is something you're going to see. It actually has a lot of applications in science, because that is what we call absolute value. And what that means is that it is, gotta wait a moment. It is the magnitude from 0. So, what's magnitude mean? We already talked about this. What's a magnitude? Pardon? Nobody remembers? A magnitude is just a distance. Okay? So, for example, me to Daniel is 1.5 meters. Everybody understand? Now, if Daniel were to walk in a circle around me, how far would he be from me the entire time? It depends on how big the circle is. But if he stays right there and goes in a perfect circle, he's always going to be 1.5 meters away from me, right? Yes. That's a magnitude. No matter where he is, he might be south of me, but he's still 1.5 meters away. Does everybody understand? In math, how many directions are there? In math class, how many? There's 4? A lot? Every number in math is where? There's 0.
Oh, horizontal.
Yeah. And how do we label those directions?
Side.
Yes, but what do we call them? What's over here?
Positive and negative.
Positive, and over here is negative, right? Now, if I tell you go to -7, you know where to go, yes?
Yeah.
Where would you go?
Left.
7 left. So there's a direction, isn't there?
Yeah.
But this symbol is only the distance from 0. Everybody understand? So here is -7, here is +7, yes? When I say -7, you all know to go to the left, right? How far did you travel, though? 7 spaces. How far did you travel here? 7 spaces. So this notation means you have gone 7 steps from 0. It doesn't give you a direction. Is everybody cool with that? So if I were to tell you to tell me where to put in an X on this line at the absolute value of 3, how many X's do I need to put on that line? 2. Where would the first one be? +3. 1, 2, 3. There would be an X there, yes? And where would the other one be? -3. Because I only cared about getting 3 steps away from 0. Is everybody cool? All right. Now, there's a reason I'm doing this. Trust me. So, since you guys have just seen this for the first time, it's not an equation, is it? Or is it an equation? It's an equation. It's got equals. So if those bars weren't there, the absolute value bars, that's what these are called, I would have y equals x, wouldn't I? And how do I graph that? What's my slope? Is y by itself? So can I put it in slope-intercept form? I can, right? So what's the y-intercept? The y-intercept is y. What's the y-intercept here? 0. And what's its slope? 1. So it would be over 1, up 1, over 1, up 1. Everyone agree? And how long would that go on for? Forever. And you can see I cross right there, right? Now you guys are smart kids. It's the absolute value of x. So if I told you x was -3, -3, what is this value here? How far did I go from 0? 3. So when I put these bars in here, if I tell you that x is negative 3, then what's y? How far is that? 3. So what's y here? 3. So now I have an x value of negative 3, 1, 2, 3, and a y value of what? Positive 3. So look what happens. This line bounces off 0 and makes the exact same line going over there. Now, what happened in these two places? What happened to the red and the blue line there? They intersected, which means that's a solution, yes? What about there? They intersected, so it's another solution. Is everybody with me? So the answer here is 1, 2, 3, 4, 5, 6, 6, and negative 2, 2. Is everybody cool? Because next year, remember I told you that next year you're going to get away from just straight lines? This is one of the ways you're going to get away from it. You're also going to graph curves. So just out of curiosity, I'm going to do something a little weird here. What if I gave you this? How many solutions would that system have? 2. There and there. Everyone cool? Okay, what if I had this system? 2. Where they cross, right? What if I had this system? Okay, what about this system? 2? 4. Why? Is this going to go on forever? Is this going to go on forever? Are they going to cross again? Understand what I'm saying? What if I had this system? 2, 3, 4. Everybody cool? Anytime the lines cross, you have a solution. No matter what level of math you're in. That's where I'm trying to go with this. Everyone's good? See how it's nothing new? It's just graphing, right? Okay. I'm done. Page 231. Work on it for 15 minutes. Then I want to do something different. If you would like some graph paper, I have a bunch right here. And of course, you could do question number 8 and 9 on this sheet. But it's right there. I want you to work for 15 minutes. And then I want to show you the next method that is a better way because it always works. Not just when it's perfect. Well, 4A and 4B are slightly difficult because of the photocopying. I don't know how well it copied for you guys. But you can see, you should be able to see, that that's where they cross, right? So, 8, 9, or 9. Am I past 9 there? It's tough to see. And it looks to me like it's going through 9, 2, yes? So your guess is 9, 2. Now, if that's the solution, what do you know about 9? It's an X. What do you know about 2? It's a Y. Oh, it should be negative 2, right? Okay, so what's 2 times 9?
18.
What's 3 times 2? 3 times negative 2. Negative 6. 18 and negative 6 is 12. So did it work for the first one?
Oh no, I thought it was a different math.
Is 9 minus 2, 11? So it works for that one. So it is an exact answer. Now this one you can see on mine, you can actually see that it is not right on a corner, is it? So for this one, it's a guess. I spelled guess wrong. You can see that it's almost negative 2 and it's almost 3. But you can't tell exactly what it is. Why? Because it doesn't cross right on a point. Everybody cool? Nobody needs to talk about 8 or 9? 7, 8, or 9 for that matter? Okay. So company A, what are the two things that are being counted there? What are your two variables? What are the two things that can change? Pardon me? The number of brochures you're printing and the cost that it's going to cost to print them, right? Which of those is independent? X or Y? I mean, cost or number of brochures? Number of brochures is independent. So X must equal brochures and Y must equal cost, correct? So if I'm going to put this in slope-intercept form, Y equals, first guy is 10 cents per brochure. So 0.1 X plus how much? 175, because when I print no brochures, it costs me $175 for them to set up to print the brochure. So you're paying $175 for them to make it up and get it ready to go. And what's the other one? Oh, it's already right here. 0.07 X plus 250. So then all you got to do is graph it. When you graph it, you find the slopes. Now, why is this difficult to graph? What makes these two lines difficult to graph? The 0.1 and 0.07 and the size of the cost, right? So it's one that you should really work with scales on, right? Well, first of all, is it ever going to be anything over in any of these three quadrants? Why not? I can't print negative amounts of brochures, and no company makes money by paying me. It's got to be up in here, yes? So I only need to graph on this side. So if I go up to 250, and I go up, and then I go up to 175, and I go up slightly steeper, that's where your thing's going to be, right? So you just got to graph. You got to set your scales. And same thing down here. You just got to set your scales. I didn't actually realize that you didn't even have to come up with the equations there. Can everybody do this? Graph two lines where they cross, that's your answer. That's the essential thing you got to take away. Now, as you can see from 8 and 9, there's situations where graphing stinks, right? Who wants to graph it? Now, just like in the last 2 units, you can also work with linear equations doing algebra, not graphing. And that's what we're going to move on to right now. Your next page should be 232. It should say solve by substitution. Now, I don't actually need to teach you this because you could do it just from reading this. So everybody have a read of what's in that box real quickly, and we'll just take a second before we go on. I'll let everybody read it. When you're done reading, that's step 1, that's step 2, that's step 3, that's step 4. Tell me if any one of those steps, not putting it all together, just if any single one of those steps is causing you grief. What do you mean by that step? Or is everybody cool with each step there? Take a second and read it.
No.
Well, it might bug him.
No, I was talking to myself.
Okay. I'm with you. I got you. Is everybody cool? Like, you might not know how to put it all together, but everybody understands the words in each step, yeah? All right. So step 1, choose one equation and solve for one variable letter. And I even give you a hint. If there's a 1 or a negative 1, that's the one you should use. So what should I use? Blue or red? Blue. Everybody cool? All right. So I've chosen my equation. I'm going to work with blue. And then it says solve for one letter. What does it mean to solve in an equation? It means get that letter isolated. What letter should we isolate here? X or Y? X. Why? Because it's already by itself, yes? So X equals 4y minus 1. Does everyone see what we've done there? This is step 1. And we are now to the point where X is 4y minus 1. Is everybody cool? Is there anybody that doesn't understand what we did there? Okay. Next, take the new equation and substitute it into the other equation. Well, here is my other equation. And it says 3x plus 5y equals 31. Now, what is wrong with this? Why can't you tell me the answer there? Because there's 2 different variables. And if there's 2 variables, you can't solve it, can you? But there isn't 2 different variables. Why? What does x equal? 4y minus 1. What letter is that? What can I write there? 4y minus 1, because x's are 4y minus 1. So if I rewrite this as 3, what can I write instead of x? 4y minus 1 plus 5y equals 31. Now how many variables do I have? 1. Can I solve it? Yeah. So how do I solve that? What do I got to do to the brackets first? How? Distribute. 12y minus 3 plus 5y equals 31. Now what? Like terms. 17y minus 3 equals 31. Now what? Add the 3. 17y equals 34. Now what? And y equals what? Pretty soon it'll all show up. Y equals 2. Now, do I have half of my answer? What's missing? The x. what do you see right here? X equals 4y minus 1. What's y? So what do I put there? And what do I get? Seven. So if x equals 7, that's supposed to be an x, isn't it? So what do I write there? 7. Now, all of you are going to be able to do this because it's not that hard, is it? But some of you are going to make algebra mistakes, aren't you? Is there a way to check if you've done it right? Yeah. Is 7, what's 4 times 2? Is 7 minus 8 negative 1? Yes. Is 3 times 7 21 plus 5 times 2 10 31? Yes. So did we do it right?
Yes.
Everybody got it? Yes. You guys try the second one. Yes. What's weird about that one? Or what? I shouldn't say what's weird. What's different? Different numbers. Can we use the same method? Which equation are you going to choose? Are you going to choose yellow or green? Yellow. I prefer green to yellow too, but from a mathematical standpoint, which one would you use? You would use the green one? Which would you use? Yellow. And so now we're going to work with yellow, which means now I have to find one variable. Should I isolate for x or should I isolate for y? Why? Because y has no coefficient. So y must equal 3 minus 2x, correct? Or some of you will want to write it as negative 2x plus 3. They're the same thing. Everybody cool? If that's what y equals, what can I do with that value and the green equation? Why do I have to do that? To find x, because you can't solve an equation with two variables. But this allows us to change this to 4x plus 3 what? What do I write there instead? Negative 2x plus 3 or 3 minus 2x, whichever one you're more comfortable with. And what does that equal? 1. Then what do? Distribute. You do grade 7 algebra, grade 8 algebra, right? So do it. 4x plus 9 minus 6x equals 1. Now what? What's 4 minus 6? Negative 2x plus 9 equals 1. Now what? Collect like terms again, because I got a 9 and a 1, right? So when I collect them, what happens to that 9 when he comes over here? What does negative 2x equal? Negative 8. So what does x equal? 4. So now I know 4 is half of my answer. What do I do with that? Comes back over here because now I need y. Negative 2 times what? 4 plus 3. What's negative 2 times 4? Negative 8 plus 3. What's negative 8 plus 3? So y is negative 5. Where else on this page is there an empty spot for y? Right in the answer. So what goes there? Negative 5. Can you check it? What's 2 times 4? What's 8 minus 5? So is it right for the yellow one? What's 4 times 4? What's 3 times negative 5? Negative 15. It's 16 minus 15, 1. So we're right for that one. Is everybody cool with that? Okay. Turn the page over. What's weird about this one? None of the variables are by themselves, are they? But what do you notice about that? They're the same. Aren't they? So what would happen if I said, for example, 4x equaled 2 minus 5y? Is that okay? Does everybody see what I did there? So now 4x equals that. What do you see right there? 4x. So what could I write there? 2 minus 5y. Because 4x is that. Does the system, wrong word, does the method still work? So if you don't have any that are a single coefficient, as long as you can make them the same, you can even do this. So you collect your like terms. 2, minus 25y equals negative 3. Negative 25y equals negative 5, right? So y equals positive 1/5. Everyone agree? Is everyone okay? If that's what y equals, what could I put there or there? 1/5. So that first one, 4x plus 5 times 1/5 equals 2. What's 5 times 1/5? 1. 4x plus 1 equals 2. What does 4x equal? 1. So what does x equal? 1/4. So what's my ordered pair? 1/4 and 1/5. Do we check it? What's 4 times a quarter? 1. What's 5 times a fifth? Is 1 plus 1 2? What's 4 times a quarter? What's 20 times a fifth? 4. Is 1 minus 4 negative 3? So are we right? Is everybody good with substitution? Yeah? What if I added a third equation? What would you do? What would you do if I gave you this? What would you do with that? You just do the same thing, but how many times? You have to do it thrice, right? You would choose your equation, isolate, substitute in, and you'd have the answer. Do you have to do it 3 times? If you do it once with any 2, will that give you a possible answer? So could you just check that answer with the third? And it might work. If it doesn't, is there a solution to that system? No, because the solution has to work in which equations? All of them. Is everybody good? Everybody cool? All right. Do page 234 for homework. Or start it now. You're going to get it done in class.
Just 34?
Yep.
Alright.
You don't have to do the puzzle sheet.